start here and we're going to talk about graphing logarithmic functions, and I'm going to add in some of the words to fill in the blanks here. So when you have a logarithmic function, logarithmic and exponential functions are inverses of each other. And we talked about this briefly yesterday, that to be an inverse, you switch x and y and solve for new y. It's when your x and y's flip-flop. It's when your domains and range flip-flop. It's when you look at your graph and it's a reflection over the line y equals x. Which means the graphs are a reflection of each other, which is what I just said, over the line y equals x. So when you find an inverse, remember that x and y are switched. Again, all things that I just said. Logarithmic functions will always have a vertical asymptote. So remember when we were in our last chapter where we had exponential functions, we had a horizontal asymptote every time. So this one's going to be vertical. So in the form x equals, and then it's going to equal whatever number depending on where the asymptote lives. Remember, like last time, typically our asymptote lived at 0, right? It normally lived at y equals 0 unless we shifted it in some way. Same thing here. It's normally going to live at x equals 0 unless we shift it in some way. Okay. We're going to go ahead and graph. I'm going to show you the first one by hand, and then we'll grab Chromebooks, and then we can do the other ones with Desmos. But I want to show you one at least by hand. You know I like to have that moment, right? Like so we can know that we can do it without a calculator or a support. Okay, so the first thing I'm going to do is rewrite this. So this is the same as y equals log to the base 2 of x. Right? F of x and y, same thing. F of x is your fancy function notation. Okay, so now I want to graph this. But do you see how, like, it's in that logarithm form, and are we super comfortable with that yet? Not really, right? So what I'm going to do is I'm going to switch it. So I'm going to switch. Remember, the base is still the base. What it's equal to is the exponent, and the value you're trying to attain is that x. So I'm going to switch it so that it's in exponential form. Because again, I'm just more comfortable, like I still like logarithms, I think they're great, but I would prefer to see it in exponential form. Now, do you see how it's actually going to be easier for me to plug in values for y? So this is a weird moment in time where we're actually going to plug in values for y instead of x. Like that's not a norm for us. Alright, so let's plug them in. 2 to the negative 1 power is what? 1/2. 2 to the 0 is 1. 2 to the 1 is 2. And 2 squared is 4. Okay, so those are my points that I'm going to graph. So in terms of x, I'm over 1/2, and I'm down at -1. Then I'm at over 1 up 0. And then I'm at over 2 up 1. And then I'm at over 4, 1, 2, 3, 4, up 1, 2. Okay. These graphs will hug the asymptote just like our last ones did, and then they will increase over time. If I tried to plug in any number I could think of, am I ever going to get out a negative value for x? Is there any exponent I could plug in to make negative stuff come out? No. So this is kind of our hard cutoff right here. That is our asymptote. So my asymptote lives at x equals 0. And now does it make a little more sense why I was picky about the y equals 0? Right? Because they're two different things. Okay, let's think about domain and range. In terms of domain, do you agree that there is no graph over here until I get above 0? And above 0 I have things. So my domain is going to be 0 to positive infinity. Both are going to get parentheses because do I actually get to 0? No, I get really, really close, but I never actually get there. So it's a parenthesis around 0. What do we think about range? Is it going to continue on? Yeah, it's going to hit all the things up and down. So negative infinity to infinity. Okay, so I'm going to pause because now we need... Okay, so we've got 2 more graphs we want to do. Our first one is log to the base 3 of x plus 4. Okay, go down here to your keyboard and press that. And then we've got to go over to... Oh, I'm sorry. There we go. Go down to the little keyboard spot so this pops up. And then click on functions. And we've got trig stuff. And we're going to scroll down. And I don't remember which one it's under, but it's here. It's under what? Oh, there it is. Okay. Do you see how there's log with nothing? And then there's log base A. So log base A is going to be when you can type in a base. This one is going to be base 10. It's going to be your common logarithm. So we're going to use log base A because we need a base other than 10. So click on that. And do we end up with a screen like this? Okay, so type in your 3. Arrow to the right until you're in that parenthesis. Type in your x. Close off that parenthesis, and then we're going to type in plus 4 outside the parenthesis. So you've got to make sure you know how to type it in and that the way it's typed in matches what's on your sheet. So do we agree those are a match for how it's typed in? Okay. All right, so now let's pick some points off our graph that we can graph. So I see a point at... we're going up through 0, but it's at 0.01, so it's really close. So here's x, here's y. I'm just going to click and scroll because I really can't see anything else right now. Let's see, 0.5. I'm going to go with 0.5 and 3.37. So I'm just picking points. Ooh, this one might be nice. Hello, are you a nice point? Oh, close. I'm going to call this... Oh, yeah. So 0, look what happens if I pull all the way over. It says 0 undefined because we can never actually get to 0. So that kind of is a nice buffer telling you where your asymptote lives. Like, hey, silly. I don't think it did. So what you'll discover is that the vertical asymptotes are a harder stop than the horizontal asymptotes. So there are times where you can touch and cross horizontal asymptotes. There are not times where you can touch and cross vertical asymptotes, especially not with these graphs. Okay, so I've got a point just a little bit over and at 0, 0.5 and up 1, 2, 3, and then over 10 up 6. 1, 2, 3, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, and just a little above 6. So remember, this has to hug the graph and then come up and go over. And again, it's always kind of nice to draw on your asymptote so you remember, okay, that's where it lives. Because remember, I told you I would take points off if you touch or cross. So where is my asymptote here? What's the equation? X equals 0 again, because it's the vertical line that comes down right here. My domain, where does my graph pick up? 0 to positive infinity. And then what's my range? What's my range? Yeah, negative infinity to positive infinity. The asymptote is where, remember we just scrolled and saw where the hard stop was, where it said undefined. Yeah, there is something that we can do to change it. This time, I see what you're saying. This time it's going to have to be in parentheses because that's going to shift it left or right. So like this is going to move my graph up or down. So do you see how if my graph slides up or down, it's still going to mind that asymptote? It's when it shifts left or right that it's going to push your next one be an example. Yes. Yep. The next one's going to be an example where we have a move in our asymptote. All right, so I don't want to have to go back to that table again, so I'm going to just try to go through and edit what I already have. So let's see, I need a base 4, so I'm going to come down here and put in a, oh, it didn't like that. Okay, just kidding, I guess I am going to type it in from scratch. All right, I'm going to go back to functions. Thought it might let me do that easier. Okay. Go back to log base A because we want to type in our base. So I want base 4 this time. And then notice that X and the -1 are in parentheses. So I want to make sure that I have all that in parentheses. So this is going to shift my graph left or right, and that's when my asymptote is going to move. All right. So we can find some points here. We've got a point at 2, 0. So that's a lovely point I can graph. If I come down here, here's a point at 1.1, comma, -1.7. And do you see how there's a hard stop there too? If I pull it over, when I get to 1, it tells me it's undefined. All right, let's see. And 5.1, ooh, there's another nice point. So those are the points I'm going to pick. I'll show you my table. Again, remember, it's not a game of pick the same points as Miss Bessel because there are infinitely many points, and that's not a game you want to play because that's not a very winnable sort of situation. Okay. So again, what I'm going to have you find are domain and range. We're not going to worry about asymptote or end behavior, or sorry, not asymptote, intercept, but I do want you to find asymptotes. So on the homework tonight, when you go to do the homework, remember those are the big 3 that I would like you to find. So domain, range, asymptote. You don't need to do intercepts or end behavior. All right, so I'm going to graph. I have a point at 1.1, comma, -1.7, so like here-ish. 2, 0, and then 1, 2, 3, 4, 5, up 1. My asymptote was at +1 this time. Because my graph, if we think about it as a translation, my graph shifted to the right by 1. So if my graph shifts right by 1, my asymptote goes along with it. So there's my graph. So my asymptote is located at x equals +1 because it was a shift right by 1. Okay, so domain. I know I go up to +infinity, but what's my starting spot this time? How far to the left can I almost go? 1. But again, I can never get to 1, so that's why there's a parenthesis there. And then our range is always going to be what? All real numbers. So -infinity to +infinity with our interval notation. Okay. So tonight I'm going to give you some more practice on what we had yesterday, as well as some graphing. The first 2, so there are 2 graphing on the front. Those you should be able to do by hand. I'm not going to police that and make sure you do them by hand, but I would, right? Like practice that, do that. And then there are 2 more graphs on the back. When I made my answer key, I made my own graphs because I felt like they were too tiny for me. But those I used decimals on. Okay, so the back 2 I did decimals, the front 2 I did by hand, and then the top part is stuff that we did yesterday. Sound good? Okay. There's one problem